Hello, this is Mr. Humbard again. For this video, I'm going to do this Chapter 3, Section 1 assignment. To start with, for number 1, we want a uniform acceleration and this velocity change. And the key word here is from and to. So from is our initial velocity, V initial, and to is our final, so V final. And then that's our time, 62 seconds. And the acceleration equation is A equals the change in velocity over our time. And we can find that as we have 62 is our final minus 32 is our initial. So it's final minus initial over 9.2. And that should give, if I do the math, 30 divided by 9.2, or 3.260, whatever. And then we round this to this decimal. It looks like x point x, so that's 3.3. All right, so for the second problem, we're accelerating from rest, so V initial from V initial, our velocity initial, then to, it's our velocity final. It's 405, and that's in 1.3 seconds. So A equals, same equation, change in velocity over time, but this time our V initial is 0. We still have the time, so we'll plug in that 405 over 1.3. Move myself over there. All right. So 405 divided by 1.3. Looks like 311.53 ... more. That's no decimals, so I round that, because that's a 5, I round that up, so 312. Okay. Number 3 is about having a car with this velocity for this acceleration at this time, and this is the initial velocity because it asks for the final. If it asks for the final and they already get a velocity, that has to be the initial. So the initial acceleration, because accelerated at rate, then time. And if we want the final velocity, we're going to have to use this equation. And we have to solve for final, so multiply both sides by t, and then add vi. So v final is v initial plus a times t. So v final is 9 plus 4.1 times 9.3. Or no, 6.3. And notice how this is in meters over seconds, and this is in meters over seconds squared, but this is in seconds. So that's going to cancel, and we get the right unit. So our V final should be 35. 9 plus 4.1 times 6.3. And I get 34.83, which it says no decimals again, so that's an 8. We round that up to 35. So, number 4. This time we have a time and a velocity change, and our velocity change is from a higher number to a lower number, so we're slowing down. It's probably landing, if it's a plane. Or it's losing altitude. So our initial minus our finals is from is initial to final over our time, 18, will give us our acceleration value. Is A equals change in velocity over time, and change in velocity is always final minus initial. So 73 minus 155 divided by 18. Negative 4.5 repeating. And it looks like I want that, so that's the same thing as 4.55, but we're going to round here, so, or no, we actually round here, x point x, so 5 rounds up, so we get 4.6, or negative 4.6. And that's acceleration, so meters over second squared. Okay. So last one. We want to know the time if we have all these values. So I'm going to use that equation again. A equals V final minus V initial over time. And I'm going to plug in what all my values are. So A is constant acceleration, negative 23, equals, if it is going, that's our initial, till it reaches that final, 322. Also the keyword until it reaches that final. So it's slowing down. So 598, 322 minus 598 over acceleration, or no, over this time. And from here, we can simplify this. (322) minus 598, negative 276 over time. And I'm going to switch the time in this, because that will just make that simple, or I'll multiply both sides by t and divide both sides by negative 23, but it's the same thing. So like so, t over negative 23. And I will get t equals negative 276 over negative 23. 276 divided by 23 is 12. We don't have to worry about any decimals. Even though it says 1 decimal, there's nothing there. So you can just put a 12 there and it won't change anything. And that's it.